So in this section, we are going to study the study design of the cohort study. And in this study design section, we are going to talk about how we select the study population, how we measure the study exposures, how we're going to conduct the follow-up, and what kind of the bias that might exist during the follow-up time, and how we are going to measure the disease outcomes, and how we going to evaluate the association between the disease risk and their exposure. First of all, let's look at the selection of the subjects. The selection of subjects can be divided into two ways. So one is the exposure group selections, another one is the control group selections. So the exposure groups is those populations that might under certain exposures, and the control group is the population that are not under certain exposures. The selection of the exposure population can be resources from different populations. First, the general populations with some common risk factors. For example, the smoking, the obesity. Researchers might including from a general population cohorts. At the general population or a particular subject of the general populations, for example, the nurses or doctors, they are commonly used in epidemiological study because these groups they can provide reliable information and they are easier to follow up. For some special exposures, we need to define and we need to select those special exposure cohorts. For example, if we are going to study the dioxin exposure and the disease outcome, we can select those soldiers in Vietnam because during the Vietnam War, the U.S. Army they delivered this Agent Orange into the Vietnam as their war strategy. Or if we are going to study the atomic bombing and the association with the disease outcome, we can select those Japanese survivors of the atomic bombing during the Hiroshima and the Nagasaki war. And now we are going to talk about how we are going to select the control group. So there are three general types of comparison or control group during the design of the cohort study, including the internal comparison group, a comparison cohort, or the general populations. So an internal comparison group, they are consisting of exposed members of the same cohort. So this is generally the best comparison group because these subjects are comparable in many aspects. For example, in the HIV populations, we can study the HIV-associated Kaposi sarcoma, and we can divide the HIV populations into those people are exposed to oral lesions or those people without oral lesions. And then we can study if the oral lesions exposures is associated with this Kaposi sarcoma. So because this is your HIV populations, so they have the same diagnosis and they might have the similar experience, and most importantly, they share the similar ability in the immune system. The second type of the selection of control group can be the external comparison group. So if internal controls are not available to select, researchers have to identify a comparison group or a control group somewhere else. But it should be stressed that the control group should have similar characteristics as exposed group that might be related to outcomes, for example, the age, the gender, geography, ethnic, or racial group. The third type of the control group selection is from the general populations. So it's particularly practical to use these general populations as the resource for the control group selection when the general populations are unlikely exposed to the risk factors, such as some particular occupational exposures. And during the study, we need to measure the exposures. So the exposures is usually the study factors that may be related to health outcomes. And the commonly used examples of the exposures including those like environmental factors, lifestyle factors, socioeconomic status, working conditions, medical treatments, and etc. And there are different measures can be used to obtain the exposure information. For example, we can obtain the data from those existing medical records. We can also collect data from the questionnaires, the interviews, or we can also obtain data or use data from those environmental surveillance or from actual physical examinations. And we can spend some time to look at these different methods. First one is called historical records. So in this type of measure, we are usually use those existing records. And the using of these existing records has some advantage. For example, the exposure studies is usually already available and for most of the cohorts, and it's relatively inexpensive to obtain. And in addition, since the data were recorded before the occurrence of the disease outcomes, the exposure information is unlikely to be biased by the outcomes. The second type is from interviews, and this is also one of the most common methods to collect data. For example, we are interested in studying some dietary habits and the disease outcome, and we can use both like interviews to do the dietary habits measurements. Third one is called physical examinations. So we can use actual physical examinations to obtain some biomedical factors, for example, some biomarkers or blood pressures. So when a medical record is not contain such information that we are interested in. The first one is called environmental monitoring or surveillance. So in case we are interested in study of the certain occupational and environmental exposures, we can use some environmental surveillance data, for example, the air or water quality in a particular locations. So when we collect the exposure data, we might need to do a follow-up in order to know the disease outcomes development. And this follow-up is one of the most important steps in cohort study. And the failure to collect outcome data for cohort members will affect the validity of study results. But usually the follow-up is a very long time process. For example, we need to follow up for 10 years to get to know their disease outcomes. And therefore, there might happen loss of follow-up. So loss to follow-up can happen, for example, a study participant, they might drop out from the study, or they move out from this country, or they just loss of contact. The researchers not get contact with these participants, and we lost to follow-up them. And loss to follow-up is one of the most important problems in the cohort study, and often leads to different bias. So when we talk about the loss of follow-up cohort studies, is usually because the dropping out is related to the exposures or outcome, and the result can be biased. For example, if people are suffering side effects from a particular drug during the follow-up period, they might drop out. So in this case, the drug might have better effect than it actually is. So it can definitely cause some bias. So in order to control this follow-up bias, we can have some strategies to control. So for example, it's better to select a stable population. So give them some motivations to participate and to improve their adherence to the study. Or we can use some statistical analysis strategies to reduce the bias. For example, we need to do some analysis to include a comparison of important study factors between individuals who remain in the study and those who have dropped out. So this is to make sure those who drop out and those who remain, they have the similar baseline characteristics, or they have similar in some important study factors. And then therefore, we will not have big problems in the selection bias. And during the study design, we also need to measure the disease outcomes. So the outcome must be defined in advance and it should be clear, specific, and measurable. Outcome can be measured during using the records, interview, or examinations. But there's one very important principle is that the measure used for the disease outcome must be identical for both exposed and control groups. Otherwise, that can cause the selection bias or measurement bias.